In this video, we're going to talk about factoring by taking out a GCF. We have some problems over here on the left. To do this, we're going to draw on some things we've talked about, which would be things like coefficients, polynomials, and creating factor trees. So before we get into it, let's briefly mention what factoring means. So to factor something, it's kind of like the opposite of multiplication in a sense. If you have a number 10, we can say we're going to factor it by breaking it down into 2 times 5. So think of factoring as just breaking something down into things being multiplied. So we went from 10 into things being multiplied down here, 2 times 5. These are equivalent. We're just changing how it's written. So factoring, break it down into things being multiplied. So that definition should probably become more clear as we look at these examples. So let's take the first one here, 12x plus 16. We want to factor by taking out a GCF. It's going to be a little bit more complex than when we just broke down the 10, but it's the exact same concept. So we're going to start doing this with a little bit of a step-by-step process, and then we'll hopefully streamline it as we go on. But let's start with just the steps. Here are the steps. Take all of the numbers and circle them. So in this case, we have a 12 and a 16. You could have more numbers. For now, we just have 2. And we're going to do what we already know how to do, which is create a factor tree for each of these. So remember, 2 branches coming off. We'll start with a 12 and pick any 2 numbers that multiply to give you 12, except 1 times itself. So you could do 2 times 6 or 3 times 4. And remember, we circle the numbers that you can't break down further. For example, 2 can only become 1 times 2, but then we have a 2 again. So we don't want to do that. If you can't break it down like that, then you just circle it. 6 we can break down though. That could become 2 times 3. 2's we just looked at can't break down, and neither can 3's. 3 would have to become 1 times 3, but then we just have a 3 again. So we're not really breaking it down. That means the 3 can't break down further, which means we're going to circle it. So as you do this more, you know some numbers can't break down. 2's can't break down, 3's can't break down, and so on. And so remember what this factor tree tells us is that 12 you can get by multiplying 2 times 2 times 3. Another word for that factor tree is prime factorization. We broke it down into the prime numbers that multiply to give us the starting number. So now we're going to do the same thing with the 16. We can break that down into 2 times 8 or 4 times 4. 2's we know can't break down. 8 we can break down into 2 times 4. 2 we have to circle. 4 can break down into 2 times 2. So now we know that the number 16 can be broken down into 2 times 2 times 2 times 2. So now what we're going to do is we're going to use this information we just found and use it to rewrite our original expression. So let's start by rewriting our first term. Our first term is just this one right here, the 12x. How can we rewrite that? Well, we just found out that 2 times 2 times 3 is the same thing as 12. So we're going to rewrite this. Let's actually scoot that up a little bit. So we're just going to swap this out. 12 becomes 2 times 2 times 3. And we're going to use these little dots to show the multiplication instead of the X type symbol, because we're going to have some variables a lot of the time, and we don't want to confuse it with the letter X. So dots for multiplication, 2 times 2 times 3. But then notice this said 12x, not just 12. So we're going to use what we know about coefficients to finish writing this first term. 12x means 12 times x. So we can write this as 2 times 2 times 3 times x. So now we've just represented this 12x in a different way. It's the same thing, we just expanded it out. And that's going to help us factoring out a GCF. So again, this process might seem a little complicated and roundabout at first, but when we do it, I think it'll make more sense once we start doing a few of these. So we now did the 12x, and now all you do is you drop down the sign. So our sign was a plus. So let's drop that down here. And now we need to rewrite the 16. So 16 we found out was 2 times 2 times 2 times 2. It's just all the numbers we circled. 2 times 2 times 2 times 2. There's no x here because there was no x up here. This was a 16. So now let's ask ourselves, is this new expression we just created equal to our original one? And it is. 2 times 2 times 3 is 12 times x is 12x. 2 times 2 times 2 times 2 is 16. So far we haven't changed anything, and that's good. When we're factoring, we don't want to actually change the value of anything. We just want to change how it's written. So that's our first major step, is getting here. Now we want to be able to take out something from each of them. Again, let's just focus on the steps first, and then we'll try to tie it together. So our next step, look at our terms. We have this first one and this second one. Remember, term means something separated by addition or subtraction. So we have these two terms here. Now we're going to circle whatever they both have in common. So for example, this one has a 2, this one has a 2. They both have 1, 2 in common. This one has another 2, this one has another 2, so they have two 2's in common. Do they have anything else that we can circle? No, they don't. This one has a 3 and an x. This one does not have a 3 nor an x. This one doesn't have any more 2's. This one has a 2's, and so on. So all we can do, they have two 2's in common. So what we're going to do is we're going to take out these two 2's from each of them. So another line. And we're basically taking these out. We're going to think of this whole thing being in parentheses. You can add parentheses really, well, you can always add parentheses around the entire thing. It doesn't change anything. So think about there being parentheses. And now we're going to take these 2's out and put them on the outside. So 2 times 2, we're taking out two 2's. And they're being multiplied. So 2 times 2 is 4. 4 goes on the outside. Now we've taken these 2's out of both of these. And now put our parentheses here because we took that to the outside of the parentheses. And what are we left with? Well, here we're left with a 3 times an x, which is 3x. Then just drop down our sign, which is a plus. And then what are we left with here? Two 2's. 2 times 2 is 4. So now we've finished. This is our answer here. We found out that 12x plus 16, you can break that apart into two things being multiplied. What's being multiplied here? Well, 4 is being multiplied by 3x plus 4. Remember, when you have something outside parentheses like that with no sign in between, we know that it's multiplication. So let's clear out some space. Just like we broke down 10 earlier as our example to 2 times 5, we just found out that we can break down 12x plus 16 to 4 times 3x plus 4. Oops, plus 4. So like we said at the beginning, it's a little bit more complicated, or a good deal more complicated once we have multiple terms, polynomial, but this is what it would look like. So again, what is our answer? Our answer is the 4 times the 3x plus 4. We can check our work. So we can also draw on something we've talked about, which is distributing, distributive property. And we can double check this. We have a 4 times 3x plus 4. So just like when we had the 10 becoming 2 times 5, you could double check that you factored it correctly. Multiply 2 times 5, make sure that's 10. So we can do the same thing here. We can multiply these together and make sure it's equal to our original expression. Let's try. 4 times 3x is 12x. 4 times positive 4 is positive 16. So we won't go too much into the checking them in this video. That's just to kind of help connect it to another concept we've talked about. So there's number one. Let's try number two. Two differences we notice right off of that. One is we have subtraction instead of addition. Turns out that doesn't really matter or doesn't really make that much of a difference. And also our x is now a y. That also doesn't matter. We're just going to use a y instead of an x. That doesn't change our process. So let's go through it, circle our numbers, create a factor tree for each of them. 15 can become 3 times 5. Neither of those can break down. 10 can become 2 times 5. Neither of those break down. So a little bit shorter trees on this one. Now let's rewrite this. So again, we're going to rewrite this expression, just all expanded out. Let's start by writing our first term, 15y. We just found out that 15 is 3 times 5. So let's rewrite the 15 as 3 times 5. Also, we know that 15y means 15 times y. So let's just add that times y on the end. Again, next we just drop down whatever signs in between. So in this case, minus. And then the 10 we're going to rewrite as the 2 times the 5. And again, there's no variable here, so we don't put one down here. So again, from here, we want to picture this whole thing being in parentheses. And we're going to take out anything that they both have. So first, let's see what they both have. We have this first term and this second term. What do they have in common? Well, they both have a 5, and that's it. So all we can do is take out this 5 and put it in front of the parentheses. So we're taking a 5 out of each of them. So we just put a 5 on the outside. Careful, don't multiply the number from one term to the number in the other term. You don't want to do that to get 25. You're taking a 5 out of each of them. So you just put 1 5 on the outside. If you were to multiply this 5 to whatever's inside, it's going to automatically go back to both of them. So 5's on the outside. Now the 5, think of it as being gone from both of these. And so ask yourself, what do you have left? On this one, we have a 3 left and a y left. It's just whatever you didn't circle originally. 3 and a y, you multiply those together. 3 times y gives us 3y. Drop down our sign, which is the minus. And then what did we not circle on this second term? 2. And that's it. So just drop down the 2. And now we've finished factoring. This is our answer. Again, you could double check your work. 5 times 3y would give us 15y. 5 times negative 2 is negative 10. We get 15y minus 10, which is what we started with, so we know we did it correctly. But again, this was just double checking. That's not part of our answer. So just the green circled part down here is our answer. So now number 3, I encourage you to pause the video and give this one a try. And let's go ahead and have a look. 6x plus 8. So we'll breeze through this one because we talked about some of those steps. Circle the numbers. 6 can become 2 times 3. 8 can become 2 times 4. 4 can become 2 times 2. Make sure to circle the ones at the end. It may be helpful to maybe put a box around these original ones so you don't confuse them with the prime numbers at the end of our branches. And make sure to circle those ones on the ends. Now we're going to rewrite them. So 6x we're going to rewrite as 2 times 3 times x. Drop down our sign, which in this case is plus. And now the 8 we're going to rewrite as 2 times 2 times 2. So we have our 2 terms here. Think of the whole thing being in parentheses. We're going to pull to the outside anything that they have in common. Because anything that's on the outside just goes to everything on the inside. So circle what they have in common. They both have a 2. And that's it. That's the only thing they have in common. And you can double check. So we're going to take this 2 out of both of them and put it out front. So now we have a 2 and then our parentheses. 2's on the outside now. Now look at what we didn't circle. On this one, we didn't circle the 3 or the x. And you can notice we have that multiplication between them. Can't really see that dot now, but the dot's there. So 3 times x just gives us 3x. Drop down the symbol. And then here we're left with 2 2's. 2 times 2 is 4. So there's our answer. Now let's look at this last one. This one has a little bit of a different situation that comes up. Let's start off the exact same way. Oh yeah, we said let's maybe put boxes around these so we don't confuse them with our circled numbers. So factor tree, 9 breaks down into 3 times 3. 18 you can break down into 2 times 9 or 3 times 6. Yeah, either one works. You get the same thing at the end. So 2 can't break down, but 9 can become 3 times 3. Now we're going to rewrite this. And again, we're going to notice a catch that comes up, something that you might be confused on what to do. Let's see. 9x can become 3 times 3 times x, just like all the other examples we've done. Drop down the sign, which this time is minus. 18 becomes 2 times 3 times 3. So same process we did before. Pretend this whole thing is in parentheses, or think of it being in parentheses, and let's circle what they both have in common. We have one term and a second term. What do they have in common? They both have a 3, and they both have another 3. So let's take out both of these 3s. So we're taking 2 3s out of both of them. So 2 3s, we're thinking in terms of multiplication. 3 times 3 is 9. So put the 9 on the outside, put our parentheses here, and then put whatever's left over. Just an x minus 2. So 9x minus 2. So this one actually was set up not how I wanted to. I wanted it to show something a little bit different. So this is just an example like the ones we've done. Let's add one more so we can see this case that comes up. Let's change it to 18x minus 9. That'll do it for us. So there is nothing special or new about that last one. There will with this one. There will be. So let's take 18x minus 9. Breeze through the beginning again, because we just did a factor tree for these numbers. 18 would become 2 times 9. 9 becomes 3 times 3. 9 becomes 3 times 3. Let's rewrite it. 18x becomes 2 times 3 times 3 times x. Drop down the subtraction symbol. 9 becomes 3 times 3. Think of it being in parentheses, and then circle what they have in common. So they both have a 3. They both have another 3, just like last time. So what's going to be different here? We'll start to think about it. We're going to take out these 3s, the 2 3s from each of them. So we're going to have 9 on the outside, just like the last problem. But here's where it's going to get tricky. So let's continue on like usual. Here we have a 2 and an x left over. So we're going to put 2x, drop down our sign, which is minus. But then what are we going to put here? Because this time we're taking out both of the 3s. There's nothing left to put. There's nothing that we didn't circle. So what do we put there? What do you think? Any ideas? Whenever there's nothing left, you're always going to put a 1. That's something you can just remember. So we'll circle our answer, and then we can talk about why that is. So if we have 9 times 2x minus 1, we said we can always check our answers by multiplying these things back together by distributing. So if we have that original expression, the 18x minus 9, we're just taking that from over there. We know if you do 9 times 2x, that gives you 18x. And then we're saying 9 times what? Let's maybe change that color. 9 times what? If we don't know that this is a 1 yet, 9 times something gives us a 9. Well, that's why it has to be a 1 here. So if that explanation didn't make sense, don't worry. Just know that if you take everything out, you leave a 1. But again, this green circled expression at the bottom would be our answer.